Okay, let's look at 4. 4a. Anybody have an issue with 4a? Yeah.
That was like the easiest
Small
problem.
issue. Yeah. Make sure that should not be. This is not in the denominator. If you're going to subtract exponents, remember, anytime you subtract exponents, those either go next to your fraction or in your numerator. You could write it like this. That would be okay. The other way that you could do it is you could just do canceling. So you could basically just go 4 of these x's, cancel with 4 of these x's, and there's 3 left over. And you could do 3 over 4x to the third. I think that's the easier way to go
Oh,
about it.
if we did.
So it's either negative on top because you subtracted exponents, or it's positive on bottom because you canceled 4 x's with 4 x's and there were 3 left over in your denominator. Okay? All right, 4b. So basically here, all we were really checking for is to see if you could figure out what cancels and what doesn't. All right? So do x plus 7 and 7 plus x cancel?
Yeah.
Yes, because addition can be flipped. Okay, so those cancel. Do x minus 5 and 5 minus x cancel?
No.
Not right away, but they can. What do we have to do to get them to cancel, Brody?
Times -1.
Factor out a -1. You can't multiply by -1 unless you do it in your numerator and denominator, which would flip both things. And we don't want to do that. Okay, but what you can do is, so we're down to x minus 5, x minus 3.
Am I right? Was that right?
If you take out a -1 from here, which is, I believe, where Patty, yep, that's where
Okay.
Patty took it out from, okay, then this changes from 5 minus x into -5 plus x.
This is.
Why do these two things cancel even though they don't look exactly the same? Patty?
Okay, well, even though they don't look exactly the same, they're still the exact same thing. -5, they're both -5s, and they're both positive x's.
Right. They're both -5 and they're both positive x's, so they really are the same thing. Those cancel. You can leave your answer like this, or you could distribute the -1 down here. That's all fine. You could have just taken it out of the top and distributed it up there too.
Oh, I forgot to do a parenthesis on the side of it.
Oh, that's all right. Sam.
I always get confused with the -1s. How do you know when you have to use them and when you don't?
Yeah, can anyone give an easy explanation? There's actually a really easy explanation for when you have to take out the -1s. Patty?
When they will make them cancel. Like you could.
Well, let's pretend that there are people that don't immediately notice or recognize that. How would you explain it to them? Like, we clearly don't need to take one out here, okay? But look at here. Some people might think, well, what if we took a negative out of here? That won't work there. It's one specific situation. Brooke?
When there's like a positive and a negative x on the bottom.
Yeah, can we word it even simpler than that? It's flipped subtraction. It's when you have, so you've got a bunch of parentheses, okay, however many, and you're looking for a situation when one of them is a minus b and one of them is b minus a.
Okay.
Okay, so if subtraction is the wrong way around, that's the time you want to take out a negative, because they're both subtraction, but in this one the a is positive and the b is negative. In this one the b is positive and the a is negative. If you take out a -1 from one of them, it'll make a match.
That
Yeah?
makes a lot more sense.
Alright.
Thank you.
Ava?
So your answer could be x minus 3 over negative x minus 3.
Yeah, that'd be fine. Yeah, if you distribute that -1 and get -x minus 3 on the bottom, that's all good. Yep.
I'm gonna be on YouTube.
It's not really YouTube.
Other things on 4b.
She's going with it.
Oh, I can help it.
Okay. Let's look at 4c. 4c should have been really, really straightforward. So your numerator was regular old door problem factoring. Multiply to 10, add to 7. You should get x plus 5 and x plus 2. Your denominator was difference of squares, x plus 5, x minus 5. Cancel out the x plus 5s. You get x plus 2 over x minus 5. That's exactly right. Nothing to change there.
I did that one.
Great, I'm so proud. D. D, you had to factor using split the middle, right?
Yeah.
Patty? Yeah?
I confused myself because I thought that was negative. I was like, there's nothing that works there. So I was like so confused, and I was like, why is that one plus? And that one was minus. So it was totally wrong. But then I fixed it because I realized that one was that one it was I was doing positive.
Alright, Patty,
I don't
alright.
understand
Nobody
that
does
at all.
And not a negative, so that's why I was like, Mr. Straight, that's so stupid. Because I realized that was positive, not negative, and I was questioning my own work before, my own work before was right.
Thank you for that. Okay, here's the idea. Factor using splitting the middle term. What you should get is 2x plus 3 times x minus 1 over 3x plus 2, also times x minus 1. Those cancel out. You get 2x plus 3 over 3x plus 2.
Voila!
If you're having trouble with that kind of factoring, I'm pretty nice on your test. There are not too many that you have to factor using split the middle. I would say that 90% of your factoring is like this one or like this one.
But I don't. Sorry, I have a question. This is like it might not exactly be considered dumb.
Mr. Strange.
Where is the one that I? Oh, it's right here. How do you factor that?
Patty,
Patty, we're not there
there yet.
We'll get there. I promise we'll get
But
there.
it's different to
If not
squares.
today, then
But
at
no,
some
but it's
point.
9.
Sammy,
Sorry, this might be a dumb question, but I always forget which one you add to and which one. Is it always the
add to the middle, multiply to the
Is
last.
it always that?
Assuming you're in descending order, so you need to make sure you're always writing it in the right order. But if you're always doing x squared, then x, then number, yes, it's always add to the middle, multiply to the last. Okay? Okay, do we have a 4E? Was there a 4E?
You didn't do D. Oh yeah, you just.
I just did D.
Oh my
There's no E? Okay.
Oh, no.
Let's go to 5.